Hi, so today I'm going to be going over how to install the toolkit and a bit of a user guide for once it's installed. So first, you want to head over to my GitHub. So if you just look up Nathan Pacey online, it should show up with my GitHub here. And if you go to repositories, you can find the virtual power plant. So the first thing you're going to want to do is download a zip of this project. And once that's downloaded, you can see its progress on the top right here. You'll find it in your downloads folder. So if we actually go to downloads, we can see we have this zip file from the GitHub. Now you can extract it and choose where to extract it to. Um, I've already done this, so I'm going to extract it into my desktop. So I have it here in this folder. So the next thing you're going to want to do is look up Python download. Now this can be downloaded on Windows, Mac, or Linux. It should be fairly straightforward. You're just going to look up the Python website and then simply just click download. Now, once that's downloaded, it will take you to their installation file, their installation wizard, I guess. And it'll pull this up. So you're going to want to make sure to click use admin privileges and add path. So it's going to come up with, do you want to make changes? And then it's going to install the latest version of Python on your device. So once that's installed, you want to make sure that you actually have Python in the same directory, in the same location as you're going to be wanting to run your toolkit from. So since I already have Python, I'm just going to shut this down for a second, but you're going to want to go. So I have my folder as the BCSE in my desktop. And to check if I have Python properly installed, I'm going to right click, or for my laptop, I like use two fingers to click, open in terminal. Now we have the directory from my desktop. So you can see I have the BCSE folder. So to check if I have Python installed, you're just going to type Python space dash dash version. So I have 3.11, and once the install works, I'll have 3.12. So I'll just leave that running. Now that I know that I have both the toolkit extracted into a folder that I want, so you can actually see what that looks like here. We want to go into Flask app. That's where the actual app is located. And this is where we're going to be running our toolkit from. So to do that, we're just going to open it in terminal again. You can see that now I'm in Flask app. And if I list everything, you can see these are all the files on the directory. You don't need to do that. That's just so you can see kind of where you are. Now to get all the installs set up and do everything, we're just going to type in Python space and then new installs like so. And we're going to click enter, and that's going to install all the packages we need and actually start the toolkit. So that's going to take a second to run. I'm just going to show you, this is what the successful Python looks like when you install it. So you can just close that when it's done. And then we can actually look at what the toolkit looks like once these installs are done. So one thing I should add is that we're running the Flask app. We're going to be running app.py. So it's a Python file that uses the Flask framework. So it's some web development framework that runs using Python. So the only thing that we're doing and installing here is the Python programming language and then the custom application that our team built. and then we're running that application. So all these packages that are being installed are all the ones that actually use in the application here, you can see. There's some other things like the static information. So that's like the data sheets we use in the website can all be found in the code um, under static. And I will be going over more information of the actual code, how to change it, and kind of a developer's guide to the toolkit in a subsequent video. Here I'm just showing you what it looks like to actually get the packages installed. So you can see we're actually getting the packages that need to be installed for the toolkit. It just takes a second. I know that opening a terminal can be a bit tedious or it can be a bit frustrating, but it should be fairly simple to get set up, especially since we have the installs um, Python script that actually handles all of it for you. So once all these packages are installed, the install script should also start up the toolkit application. It actually by calling or running the app.py file. So we actually get a warning at the top here, but shortly enough, we'll see the actual toolkit port or IP address that it'll be running on. Um, so now we can see the toolkit is running on the server, and there's a link here that we can click. So if you press Control, click, now in your Chrome or whichever browser you use, you'll be able to access the toolkit. So why don't we test it out? I'll input my postal code, some surfaced area. I'll do roof mounted solar at about 35, 34, and we can see that it's actually up and running. So all the plots are interactive, meaning that you can zoom in to the data that you want to see, as well as hover over them. I'm looking at the hourly buyback pricing histograms for the day. You can do the same thing for different generations in their yearly revenues. The red line here for each one of these plots represents the calculated generation. So that's the generation that the toolkit actually came back and calculated. So you can see that red line. Um, so I know for like the fit and microfit projects, they had some higher pricing. So say you don't want to be looking at these smaller payback periods or return on investments. You want to be over on the right and see actually what that is. You can zoom in basically as much as you want by dragging over the data, and you can now see at the prices what that payback period is going to look like. So, I mean, really briefly, it looks like about 5 years payback for our generation at about zero point 0.4. Um, and then you can do the same for ROI. You can zoom into any point. I think the turning point is a really important metric. So if we actually want to look, we can see that 0.07 is our break-even point for the yearly generation that we calculated, and then subsequently it's less for less generation and more for more generation. Say you want to keep this view, you can click the pan tool and you can scroll by to see exactly when that break-even point happens for each one of these generations. Say you want to go back to reset, you just click that home button. And if you just want to generally zoom in or zoom out, you have that ability here, the reset button. And this is just some of the documentation for the actual plots and how they work. Um, yeah, so that's how that works. Say you want to reset the axes, You can also just double click when you're in the zoom tool there. So that's the solar page. We have basically our energy insights, which is a lot of temperature and climate data. We have our payback sensitivity analysis at the bottom, along with our hourly pricing from IESO for the generation period and the subsequent revenue. We also have a location page where you can utilize Google Maps and see exactly where your data is coming from. It also has zooming in features, zooming out, satellite and I guess normal Google Maps. You can see exactly how far away it is as long with the exact address and elevation. Mine's specifically in Waterloo, Ontario, so you can see just exactly where that's coming from. We also have pricing data, so that shows you the IESO's hourly pricing. You can see the average with the standard deviations. So you can see just exactly where we're getting these hourly prices from when we compare the generation, like I showed at the very bottom of the solar page, which would be the same as the wind page. So this is exactly where that pricing data comes from. We have links to it as well, where you can see the IESO's website. We also have a battery page and a wind page, but I didn't put any of those inputs in. So why don't I do that again? I'll choose a different location. I'll add a large solar. Let's make it one axis tracking, premium, 5 wind turbines, make them nice and tall. Say I want to add battery storage. I just click on that button there. And then these two are the mandatory inputs, and these are additional. So you need to know your hourly demand. So say it's something like 10 kilowatts and you need that for 5 hours. That determines your battery capacity. That's the size of your battery. Say you know that you have a maximum number of cycles or a maximum retention. So that's like the battery degradation, that final capacity that is mostly for safety, but it can also be for your project's requirements. So for example, you could say, I never want the battery to go below 70% of its out of the box capacity or out of its box retention, I should say. Then you can put in 70 here. But say that you know it shouldn't exceed something like 10,000 cycles, you can also put that in. So now I have a system with a bunch of different inputs. I click submit and we get the solar data as well, but we can also look at the wind page and the battery page to see just what those insights look like too. So I get the different wind speeds along with the project metrics, some of the fitting curves that we use for interpolation. That's the average one there. Then I'm going to get the actual average or the hourly wind speeds that we use to calculate generation. And you can do the same thing, zooming in for each one of these points, along with the hours of the day, how that wind speed fluctuates at your location throughout the day. And then your associated power generation per month from wind energy, along with all the same financial analyses, with the calculated one being the middle red line for each of these plots. So then if we look at our battery page, we have a similar but a little bit of a different setup where we mostly look at the degradation of battery. So you can see here the different cycle numbers of our model, and you can actually see the research paper we get this model from here. As well as the state of charge. So the different state of charge associated with how you charge your battery, whether you're charging it from 25% to 100 or 25 to 85% on each cycle. Then you can see the year-long effects of the degradation as well as your lifetime according to the inputs you put in. So for me, it was that maximum of 10,000 cycles along with the actual capacity of the battery. And you can see the revenue and associated lifetimes for each types of state of charge. Yeah, and of course you also get the revenues. Then once you've clicked all your pages, you can get a project summary where it has all the, I guess, larger metrics of your total project instead of just per system basis. The last thing I should mention with the toolkit is the contact page where you can get my details, and you can reach out to me if there's anything you want to know. I can't guarantee I'll be super helpful, but that's basically the overview of the toolkit and what we've implemented here. So I should note that it's all being run locally, so it is run on your terminal. So if you were to stop your program by either exiting it or pressing Control C, you actually will stop your ability to run the website on your local device. But if you just click that new installs, or if you write Python app, you can run the toolkit locally again. So you can click that link and it'll be back up and running. So just to give a quick overview of the startup, you want to download the folder from the GitHub, which is a zip file, extract it to somewhere that makes sense for you on your computer, whether that's your downloads folder, your desktop, documents, or some other folder that it can be locally accessed. You want to download Python in order to run the code. Then you want to go in to the folder, specifically go to the Flask app portion, open a terminal here, and in order to get all the installs and run the application, you're just going to type Python and then new installs. And that's all you need to do to run the and get set up with the toolkit. Once you've run the installs one, you don't need to do it again. And instead you can run Python app. And that will just be quicker to get the toolkit up and running for the second and third and fourth time. So yeah, I hope this is helpful, and I hope the toolkit works for you. All the best. Thank you.